I'm going to solve this question using chain rule, so I want to pay attention. In chain rule, if you have a function that has another function in itself, if you want to differentiate that function, the method that you're going to use is chain rule. Are you getting what I'm trying to say? Chain rule is used to differentiate a function of a function. That is, if you have a function that has another function in itself. A typical example of such function is fx equals to 4x plus 5 raised to the power of 4, because 4x plus 5 is function itself. 4x plus 5 is a function itself. So in differentiating this function, hello, please pay attention. According to chain rule, dy all over dx equals to dy all over du multiplied by du all over dx. Are you getting it? If you want to find the derivative of a function dy dx, where y is equivalent to the function that you have here. But for this now, I'm going to have dfx all over dx will be equals to dfx all over du multiplied by du all over dx. Do you understand? The reason why it is this is because what I have here now is not y. Are you getting it? It is fx. But this formula is still similar. They are the same. They are not even similar. They are the same. Are you getting what I'm trying to say? The only difference is that because what I have here now is a function f of x, it is not y. Assuming I have y equals to 4x plus 5 raised to power 2, I'm going to engage this. Are you getting it? But now, it is no longer y that I have here. What I have here is f of x. Do you understand? So now, let's go. To differentiate this function, f of x equals to 4x plus 5 raised to the power of 4. The first step is that you have to set u equals to the function inside the bracket. You understand? The function inside the bracket is what? 4x plus 5. So I'm going to have let u equals to 4x plus 5. Do you know? Hence, if u equals to 4x plus 5, f of x will now be equals to u raised to the power of 4, because now u has been equivalent we have set u equals to the function which is inside the bracket. Are you getting it? So f of x will now be u raised to the power of 4. Do you understand? Okay. Now, according to this formula, we need the derivative of f of x with respect to u. Do you know? So I'm going to have the f of x all over du equals to, now, using polynomial rule, if you differentiate u raised to the power of 4, what are you going to have? 4u raised to the power of 3, right? Yes. Okay. Now, according to this formula, I also need the derivative of u with respect to x. So I'm going to have du all over dx, which is equals to differentiate 4x. You're going to have 4, right? And if you differentiate a constant, you're going to have what? 0. So the derivative of u with respect to x is what? Is 4. Okay, now let's go back to the formula. The derivative of f of x all over dx will be equals to the derivative of f of x all over du. Derivative of f of x all over du is equals to 4u raised to the power of 3. So I'm going to have 4u to the power of 3 multiplied by the derivative of u with respect to x. Derivative of u with respect to x is 4. So I'm going to have 4u raised to the power of 3 multiplied by 4. You can see that it's simple. So from this point, I'm going to have derivative of f of x. Hello, listen to me carefully. What I have here is still the same thing as this. Are you getting it? You can write the derivative as this, and you can also write the derivative as this. Do you understand? So don't get confused. They are the same. So f of x, derivative of f of x is equals to 4. Now listen to me carefully. Don't forget that we have already set u equals to what? 4x plus 5, right? So instead of u, I'm going to replace u as 4x plus 5 in this. Hence, I'm going to have 4 multiplied by 4x plus 5 raised to the power of 3 multiplied by 4. You can see that it's simple. Okay, we are not done. Derivative of f of x will be equals to, now, 4 times 4. What is this? That's 16, right? So I'm going to have 16 multiplied by 6 16 multiplied by 4x plus 5 raised to the power of 3. So that is the final answer to that question, okay? And if you like, you can proceed to expand this bracket, but for the sake of simplicity, you can put it like this. Do you understand? Okay, now, the reason why I'm emphasizing on this is because you can see that if you compare this function, x squared plus 1 to the power of 2 and 4x plus 5 to the power of 4, you can see that this function itself has a power. So you can also use chain rule to differentiate this function. Are you getting it? Without expanding, you know, when I'm solving this question, okay, when I solved this question back then, I expand the bracket, then I take the derivative of u, right? But you can also use chain rule. Let's go. According to chain rule, if, let's say, please listen, what I want to do now is that I want to differentiate this function to show you that you can use chain rule to differentiate this. You are going to have this. At the end of the day, you are going to have this answer, even without expanding. If u equals to x squared plus 1 raised to the power of 2, and we want to find the derivative of u. Hello? According to chain rule, the first step is that you have to set the function inside the bracket. You have to set it equals to a letter. Are you getting it? So let us use t. Let t equals to x squared plus 1. Are you getting it? Now, if t equals to x squared plus 1, that means that u will be equals to t raised to the power of 2. Is that not it? You can say that it's simple. If u equals to x squared plus 1 raised to the power of 2, and we've already set t equals to the function x squared plus 1, so u will be equals to t raised to the power of 2, right? Yes. Now, du over dx will now be equals to du all over dt multiplied by dt all over dx. Are you getting it? Oh, dt over dx, sorry. Du over dt multiplied by dt all over dx. So now, with respect to this formula, I need the derivative of t and the derivative of u. Derivative of u with respect to t will be equals to what? 2t, right? Yes. And the derivative of t with respect to x will be equals to dt all over dx, which is what? 2x. So from this formula, du all over dx will be equals to du all over dt is what? 2t. So I'm going to have 2t multiplied by dt all over dx. Dt over dx is what? 2x. So I'm going to have multiplied by 2x. Now, don't forget, please pay attention. Don't forget that t is what? X squared plus 1. So I'm going to have 2 multiplied by, instead of t, I'm going to replace t as x squared plus 1. So I'm going to have x squared plus 1 multiplied by 2x, right? So I'm going to have du all over dx is equals to 2 times x squared, that is what? 2x squared. 2 times plus 1, that is what? Plus 2, okay, multiplied by 2x. Do you understand? I first use these two to multiply all the elements, all the terms that I have inside the bracket. So I have this. Then don't forget that this 2x is also multiplying all of them. So I'm going to have du all over dx is equals to 2x times 2x squared. That is what? 4x squared, 4x cubed. 4x cubed. Now, 2x times plus 2, that is what? Plus 4x. So the derivative of this function is 4x raised to the power of 3 plus 4x. You can see that it is still the same. We have the same answer, just like when I expand the bracket and I differentiate using polynomial rule, I have this answer, right? Now, when I expand this without expansion, using chain rule directly, you're going to have the same answer. Do you understand? So the reason why I'm emphasizing on this is because you might have a function that you might not, you will not be able to expand it. For example, let's say the power to which this function is raised to is 9. Are you going to be expanding? No. You employ this rule directly. Use chain rule directly. Do you understand? Because expansion sometimes can be tedious. So I'm just emphasizing on that to help you to comprehend it. Now, You might be wondering that according to this formula, I said it is du. I use the fx over du here times du over dx. Then in this place, I use du over dt times dt over dx. The formula is still the same. Are you getting what I'm trying to say? The variable is what changed. Do you understand? The formula is still the same. So take note of that. Now, let's look at the question that we have on the board. We are asked to find the derivative of the function f of x equals to 1 plus x to the power of 3 over 2 multiplied by 1 plus 2x squared. Okay, you see this function as well is it has two parts, and these two parts, they are multiplying each other. And to watch the complete class, kindly click on the link in the description of this video or the comment section. Okay, see you in the next class.